Hello everyone, welcome to our group computer vision project. So here's a brief introduction about our project. Our project is focused on developing and enhancing a better face recognition system for smart door lock. It is designed to improve the home security and provide convenient keyless access for the household member. And the type of the computer vision problem of this one is supervised learning, which also object detection, because it's face recognition and face detection. So who are our target user? Our target user are the homeowner and the families who seek for a more secure and convenient way to enter their home without relying on standard keys or passcodes. Moreover, we think that this also might help the elderly individuals and people who have disability. So this will offering them more accessibility and more convenient. The main datasets we collected from the Kaggle human face dataset. We collect around 2,000 images for this. The reason why we choose the dataset because it includes a variety of human face under different pose, angles, and lighting conditions. This diversity will help to improve our model and its accuracy in recognizing face. Next one is our dataset. Our dataset includes 60 facial image under various lighting, condition, facial, and pose. How we do it is that we annotate it manually using the VGG image annotation. And then from that, after we annotate it, we export into JSON file, and then we convert to the Zolo TXT file label format for compatibility. So here is just the start of our training progress.
For our training, we have trained a YOLO V1 nanoface detector, which is already on the internet, where this code is used to detect faces for larger and for industrial level of uses our database. So we use it for our 2000 image database. The goal was to learn robust and generic face patterns first and before testing our own models. So for our initial results on the data splitting, we divided it into train, validation, and test using AT 1010. And the same split was applied to our 60 custom images when building a YOLO structure. And for our confusion matrix, the model correctly detected 52 faces, missed around 8, mostly side-angled or dimly lit, and produced 5 false results. In short, strong on the frontal, well-lit faces, and weaker on the long contrast scenes. For training and validation graph, the graph drops steadily, and the accuracy trends to go up, which shows the model is learning without obvious overfitting. It works reliably for now, just on the frontal face, but struggles under backlight and strong shadows. And then for our normalized confusion matrix, it shows 87% of actual faces were predicted correctly. 13% were missed false positives, were mainly background regions that resembled faces. Overall precision was around 91%, and the recall was 87%. Had some issues for side profiles, shadows, and strong lighting condition, and partial faces. So for that, we had divided the 2000 images into 1600 plus 200 plus 200, where 1600 were trained on a different code base, and then the other 400 were trained based on the relaxed thresholds of an augmentation. But yeah, we need to work on two more models where we will implement one for external dataset and then another for combined, so that at the end it can recognize the facials with the red labels, and then produce more accurate results.
So you can see here is that some of the image that we collect is facial recognition. We think that this happened because the limit of the GPU usage in the collab after training a lot of datasets. Another reason is that because of the auto annotation limitation, because it's lack of data, like the diversity and data, which leads to the limit in the auto detection for the models. And finally, it's because of the bias. We found that most of the face that under clear frontal and well light condition is successfully detached. But however, some of the side profile or the image in the dim light or some of polycover face is struggle for the models to recognition. In the conclusion, there are some part that we think our model will succeed, and some of the part might fail. So I would say that it will be succeed in recognize an image that have perfect daytime or like front image, like front face of the image. However, the thing that might fail is that it will struggle with side angle, poor lighting, and maybe some with people with mask or hoodie on them. So we come up with some solution for the fail. We will add brightness and artificial shadows to make the image become more lighter, so it will be easier to recognize the face. So we're gonna introduce some random lighting in it, and we will use random brightness contrast to do it. And moreover, we will collect more diverse and data sets so that the model can train with diverse data. We also gonna add combined training model for train, just like the code that you see. And we use both of our data sets together during the training, and also validate on our own 60 image sets for bias and confusion. Lastly, we're gonna add identification after the detection stage to improve our models. And I would say that is everything about our group presentation. Thank you for listening, and let me know if you have any more questions. Thank you so much.